What we're doing today is solving rational equations. So one method to solve these is to get a least common denominator for all the fractions in the equation. So what I would do, we need to kind of think about what would that be. So first off, if we just had regular fractions, if we had just 1/3 plus 1/6, and we wanted to add those, well, how do we find the common denominator, least common denominator? We think of a number that both 3 and 6 go into, the lowest one. Well, that would just be 6. It's no different here with this 3 and 6. So that's going to be at least part of our least common denominator. Now let's look at the variables. We have n squared in each denominator, so they have that in common. So that also has to be in our LCD, okay? And so now we need to make each of the denominators look like this. So we have to think about, like, what does this need to be multiplied by to get this? Well, 3 times 2 would be 6, and then we're good on the n's, right? We still have n squared. So we're going to multiply this first fraction by 2 over 2. I can squeeze that in there, 2 over 2. All right. The second fraction here, I'm missing a 6 here, so I'm going to have to multiply this by 6 over 6. I'm just going to kind of write it like that, okay? Let me zoom in here just a little bit here. All right. And then this one I don't need to worry about at all because I already have the LCD. All right, so let me do that. So I'll end up with 2 times 2n plus 2, a lot of 2's there, over, again, this will be 6n squared. And then this one gets multiplied by 6 over 6, so I'll have, well, 6 times 1 is 6. 6 times n squared is 6n squared, like I want. And then the other fraction over here didn't have to get multiplied by anything. All right, so now I have this. Now the next step is really nice. You might already see it. In order to simplify this, to make this equation easier to deal with, we can get rid of the fractions. All we have to do is multiply both sides by that common denominator. And so what that ends up doing, if I distribute this in, it basically cancels out, okay? Let me just show that one time. I might not do this on every problem. I'm distributing this 6n squared, okay? I'm going to write it like this, and there's a reason I'm doing that. And then this one I might just already cancel. Hopefully you can see why those cancel, okay? Let me talk about why do those cancel, and that'll kind of lead to my next step. So if you have, and I'm just going to go off to the side for a second here, if I have like 1/5 times 5, or even here, let's make it more interesting. Let's say we got 3/5 times 5, okay? Well, what's going to happen here is, here, if we did this the long way, we would get 15 over 5, which would give us 3. But notice, we could have just done this, not have the 1 there even. And we would just ended up with 3. So anytime you multiply a fraction by the denominator, those are going to cancel out. So that's what's happening here. We have variables in our denominators and in what we're multiplying, but that's okay. So these are going to cancel out. Those are going to cancel out. And now we just have 2 times 2n plus 2 plus 6 equals 1. All right, a lot easier to deal with, no fractions. And then we would distribute here. We'll get 4n plus 4 plus 6 equals 1. Add those up and we get 10. Take away 10. You get 4n equals -9. Divide by 4. Get n equals -9/4. All right. Now, you might have noticed in the directions, which I failed to read, that it said to solve each equation. Remember to check for extraneous solutions. So, just like you should do on most problems involving rational expressions, you should identify excluded values. So, looking way back here, what value of n would we put in here to get to make a denominator 0? Well, that would be 0 itself. So n cannot equal 0. What an extraneous solution is sometimes how the math all works out here, you end up getting as one of your answers, you get an excluded value. It's just kind of what happens sometimes in this process. You might actually get n equals 0 or something like that, and then that would be an extraneous solution. If one of your solutions in your work was actually an excluded value, that is an extraneous solution. We might not run into that a lot, but I think we run into at least one on this note sheet here later. We're good here on this problem because this does not equal 0. So we have no extraneous solutions. We checked for it. That doesn't equal 0. All right, that was checking for it. So we're good. That's our answer. All right, you guys go ahead and try number 2. All right, I got k equals negative 23 over 4, and I did check to see if this was an extraneous solution. Nope, the only thing, k couldn't equal 0, so I'm good here. Just one little detail, don't leave that negative in the denominator, either put it in the middle or the top. Middle is really preferred. All right, let's take a look at number 3. That one looks a little bit more complicated. We have some things we could factor in this one. It didn't happen on number 1 or number 2, but we can factor. Now, we really only have to worry about factoring denominators here. Factoring numerators would be really more work than we need to do. If you think about later on, we're going to eventually combine the numerators. Eventually, you'll see that soon. Okay, so I'm going to factor this denominator. I'm just going to write down what it is below rather than writing out a whole new step. So this factors to n. I need two numbers that multiply to negative 20, add to negative 1, right? So that'd be negative 5 and positive 4. And then it's the same thing here. This is the same expression. So our LCD here, well, I need an n minus 5 in it. I need an n plus 4 in it. All right? Every factor must be present. Every factor in all the denominators must be present once in the least common denominator. Got that? Got that. I already have n plus 4. Good there. And of course, I already have those. So this is my least common denominator. So now I need all these denominators to look like this. Well, luckily, this one already does. This one already does. So I just need to multiply this middle fraction. I'm going to have to multiply it by n minus 5 over n minus 5. I'm going to actually write it out a little differently here. Let me go. N minus 5 times that, and then n minus 5 times that. Okay, so that will end up looking like, let me write this all out. Luckily, I'm not going to have to worry about the numerators, I don't have to multiply the numerators by anything on these two, since they have the common denominator as their denominator already. Okay, here, this fraction, well, 1 times n minus 5 is just n minus 5. And then those just go together. You don't need to FOIL out the denominator, for sure. And then the other side just looks the same. Okay, so the next step is we're going to, just like we did on number 1 and number 2, we're going to multiply both sides by the common denominator. And what does that do? Well, that just gets rid of the denominators. I might not write all that out because it'll get really messy. So when all your denominators, basically what it boils down to is if you have an equation, everything's a fraction, and if all the denominators are exactly the same, you can just drop the denominators because it's just like you're multiplying both sides by the denominator and then they're going to cancel out. So you just end up having the numerators left over. Now, just be careful with your sign here. We have a minus. That's got to apply to both of these. That's why I wrote it like that. Okay, so which I'm going to take care of that now. So now it's just a matter of distributing and combining like terms. So I'm going to do that probably a little quick here. So we're going to have 4n and 10. I have variables on both sides, so I need to get them to one side, so I'll take away 4n. So 10 equals 2n minus 6, add 6. Get 16 equals 2n, divide by 2. 8 equals n. All right, and now we do need to check for those extraneous solutions. You can see how that could happen. If I had like an n minus 8 as one of my in one of my denominators, that would have made that extraneous solution. What would happen then if this was extraneous? You would actually just say no solution. That can happen too. You can have a rational expression that has no solution because of an extraneous solution. Okay, but here our excluded values would just be 5 and -4, so we're good. Our answer is not one of those, so we are all good. That is our answer. All right, you guys go ahead and do number 4. All right, so I got x equals 6. I checked to make sure that was not an extraneous solution. Yeah, my excluded values were 5 and 2. The 6 is not one of those numbers, so I am good. All right, let's do number 5. At first glance, this might look simpler than number 3. Kind of looks more like number 1 and 2. This one will end up a little bit different, which we'll see here. So same deal, you want to find your LCD. Looking at the numbers, the lowest number that both 6 and 2 go into would be 6. And then looking at the variables, well, we got an x and an x. So we need at least 2 x's, or x squared. We have an x here already covered, right? Because there's 2 x's being multiplied here. So that's already covered, and then there's no x's there. So that's our LCD. So we need all the denominators to look like that. So this one already looks like that, so we're good there. This one needs an additional x, so we're going to have to multiply the denominator by x and, of course, the numerator by x. And then this needs to look like this. Well, 2 goes into 6 3 times, so I'm going to need a 3. And then I also need the x squared. All right, so 2 times 3x squared would give me 6x squared. So that's what we're multiplying that by. All right, let's see what we get here. So first fraction stays the same. This is going to be x times x plus 3 over 6x squared. All right, just writing it out like that for now. And then over here we're going to have 3x squared over 6x squared. 2 times that. All right, so now all of our denominators are the same. We can get rid of them just by multiplying both sides by 6x squared. I might not write that all out. I'm just going to drop them. So now we have this. Well, in order to solve this, I need to distribute this. And you might already see why this one is a little different than the others here. So yes, I have some x squareds in my equation here. So guess what that means? This is a quadratic. Okay, yeah, so rational equations, you can actually end up with quadratics and cubics and higher. We're just going to stick with ones that come out to either being linear or quadratic in here. The ones on the previous page ended up coming out to like a linear equation. These, though, are coming out to quadratics. So I have variables on both sides, except this is a quadratic, so remember the technique is usually to get everything to one side. I can tell that I'm going to have a quadratic term and a linear term. Definitely then we want to get everything to one side. We can't use like the square root method. Okay, so I'll have, and well, I'll do this in steps. Let me go ahead and rearrange this so it's in standard form. So I have negative 4x squared minus 3x plus 1 equals 0. And then we'll use the good old trusty quadratic formula here. I might do one other thing here. This is what I would do. You could use this, you know, a is negative 4, b is negative 3, c is 1. I don't really like all the negatives here. So how about this? We just switch the signs. Now, how am I just able to do that? Well, it's just like I multiplied both sides by negative 1, okay? So now you don't have to do that step, but I just don't like having, especially I don't like a being negative, okay? I guess that's a little bit of a pet peeve for me, but do what you will. All right, so we have, that's a, that's b, that's c. So we have negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. That's what x will equal there. Let's see, so I'm going to just go ahead and put that this in my calculator. We do want exact answers here, all right? So 3 squared minus 4 times negative 1, we get 25. Oh, that's nice. That's a perfect square. And then we'll get 8 down below here. So basically what I'll end up with here is negative 3 plus 5 over 8, right? Because square root of 25 is 5. Or negative 3 minus 5 over 8. This comes out to 2 over 8, which is 1/4. This will come out to negative 8 over 8, which is negative 1. So let me check, though, before I write my final answer, if either of these are extraneous solutions. So let's go back up here. Well, the only thing x cannot equal is 0, right? If I put 0 in here or here, 6 times x is 0. 6 times 0 squared would be 0, right? So that's the only excluded value. That is not one of these numbers, so those are both valid answers. You could use curly brackets if you want. That'd be the best way to do it. There we go. All right, you guys go ahead and try number 6. All right, so I got negative 4 and 3. One thing I noticed here, you actually could have factored this, but you could have probably saved a little time by just factoring this. That's not always going to happen. The one I did on number 5 was not factorable. You had to use quadratic formula or complete the square. So that's fine if you want to stick with the quadratic formula. It kind of works all the time. Factoring only works some of the time, right? All right, so that's what I got. And yeah, I checked to see if I had any extraneous solutions. Nope, 0 is the only excluded value here. So these were both valid answers.